before solving this question, I want you to understand one particular thing. Any number for that matter. So I'll come to this question later on. Let us first discuss any number. What exactly is a number? What exactly do we mean when we say it's a number? So for example, if I write a number like 123, if the base is not given, we assume the base to be 10, right? That is something which is by default because we are using decimal number system. All right. But just for sake of it, I'll write 10 over here. Okay. Now, if I expand this, all of you must have done this in maybe standard 3 or 4. If you expand this, this becomes 1 multiplied by 10 square plus 2 multiplied by 10 to the power 1 plus 3 multiplied by 10 to the power 0. All right. So what is this 10 to the power 0? This is units. We call it units, isn't it? We call it units. The place. This is tens, the place. This is hundreds, the place. So you must have been remembering one thing. The teacher asked when we were kids that what is the place value of 2 here? The answer is 20. So place value is basically the contribution of a digit made to the entire number. Now, 2 here. So there are 3 things which we should know. One is called the face value. So face value is 2. The place. The place is tens, right? Which we discussed here. And the place value will be 2 multiplied by 10. That is 20. The 20 is the contribution of 2 in this number. So it is nothing but 123. We call it 123. Why and is there? Because it is 120 and 3. So that becomes 123. Okay, cool. That is something which you already know. Now, the thing is, what happens if I write 123? Oh, I will call it 123. The moment I call it 123, that means I'm somehow assuming that I'm dealing with the decimal number system. So 100, 10, all these nomenclatures, all these words are used for decimal number system only. If the base is not given, we call it 1, 2, 3. We don't know what the base is. So just I'm assuming because something is not known, we call it X. Here comes the algebra part. If I expand this guy, what I'll get? I'll get 1 multiplied by x squared plus 2 multiplied by x to the power 1 plus 3 multiplied by x to the power 0. The similar way as we did earlier, like 10 to the power 2, 10 to the power 1, 10 to the power 0, and so on. If it is 4-digit number, it'll start with, in decimal number system, starts with 10 to the power 3, that is thousands, then hundreds, then tens, then ones. In case of, if I take it x, x can be anything, can be 10, can be 7, can be 6, can be whatever, depending on the number of digits they're using. So this is nothing but x squared plus 2x plus 3. Now you will be kind of surprised. The number 123 can be written as x squared plus 2x plus 3, isn't it? And here, this becomes decimal number system the moment I put x equal to 10. If I put x equal to, let's say, 7, this becomes heptal number system. The moment I put x equal to 6, this becomes hexal number system, and so on. All right. So in a way, I have just assumed because the base is unknown, let the base be x. Let it be x. Let there be light. Okay, now, so once it is x, if I want to divide this guy by, let's say, x minus 1, which in base 10, I'll just write here the base 10 comparison, which is decimal comparison. So when x is 10, the base is 10. The moment I divide it by x minus 1, that means I'm dividing it by 9, isn't it? And what is the divisibility rule of 9? You have to add the digits. Simple. x minus 1, x minus 1 is similar to 9. So if x is same as 10, x minus 1 is same as 9. So can I say that if I have to divide a decimal number by 9, I just add the digits. All right. And I will see whether the sum is more than 9 or not. We'll do, all that stuff later on. The very same 9. If I can just, kind of relate 9 with x minus 1. Okay. So in base 10, x minus 1 becomes 9. When it's base 7, x minus 1 will become 6. Anyways. Now, before going on to, divide this by 9, which all of you know that it is basically the sum of the digits, let's understand why that actually happens. So if we have a function defined on x and I want to divide it by, let's say, a, then the remainder is basically f of a. So wherever we have x, we put a, which also means if I want to divide fx by x minus 1, I'll just put 1 in all the places where x was there. Cool. That's really cool. So if I look at this thing again, if someone asks me what will be the remainder when this guy is divided by x minus 1, I'll just replace x with 1. I'll get 1 square plus 2 into 1 plus 3, which gives me how much? 1 plus 2 plus 3, that is 6. That is 6. Now, to your surprise, if the original number 123 is divided by 9, you will get 6 as the remainder because the sum of the digits, 1 plus 2 plus 3. Isn't that brilliant? So now we have proved one thing. Not just proved, I have just kind of, uh, created, uncovered all the layers of numbers which are now having an algebraic format. So essentially, I can say that all the numbers that we know of are nothing but functions of 10. And if I assume 10 to be equal to x, functions of x. So the place of 9, the place of 9 in decimal number system is very much similar to, is exactly similar to the place of x minus 1 in base x. I hope that is clear. Tell me in the comments, right? So whatever 9 does for base 10, x minus 1 does for base x, which means if the base is 7, then whatever 9 was doing in base 10, 6 will be doing the same thing in base 7. So essentially, I have just, kind of made everything to be x. So if x is 10, x minus 1 is 9. If x is 7, x minus 1 is 6, and so on. So if you want to find the remainder of fx, function on x, divided by x minus 1, you just replace x with 1, that's the answer. And when we do that, as we saw here, it's nothing but sum of all the digits for base 10. Which means, coming back to our question. So 14641 base 7 divided by 6 base 7. So here, if I assume 7 to be x, 7 to be x, then the expanded form of this will be nothing but x to the power 4, all right, plus 4x cube plus 6x square plus 4x plus 1. And this thing has to be divided by 7, not 6. And 6 for us will now be x minus 1 because x was assumed to be 7. So all you need to do is just replace these guys with x with 1. And that will be the exact remainder when divided by 6. So 1 to the power 4 is 1 only. Whatever power of 1 is, it remains 1 only. So 1 plus 4 plus 6 plus 4 plus 1. Did you realize one thing? After doing all this 5 to 10 minutes of video, we have boiled down to one simple thing, that the remainder when 14641 base 7, when divided by 6 base 7, it's nothing but the sum of all the digits. The divisibility rule of 9 is sum of the digits if and only if base is 10. Similarly, divisibility rule of 6 will be sum of digits only if the base is 7. So all in all, when someone asks the question like this, where the divisor is 1 less than the base, just add the number of digits. So here the question was in base 7 and divided by 6. So just have to add the digits. So 1 plus 4 plus 6 plus 4 plus 1. This gives us how much? Let's do that. This gives us 16. And obviously, remainder has to be less than divisor. So we just divide 16 by 6, okay, and we get 4 as the final remainder. Moreover, there is also a kind of magical technique to do the same thing. It's the same thing, but just framed in a different way. So you know that if you have to divide something, with let's say 1, 2, 3, 4, 5, divide by 9, what's the remainder? Just cancel out all the digits which add up to 9. So 5 plus 4 is 9. Just cancel them out and add the remaining ones. You get 6 as the answer. Wow. So similarly, for our question, which had 14641 and the base was 7, we divide by 6. You just do the same thing. Just cancel out all the 6s. 6s cancel out. 4 plus 4 is 8. Out of 8, 6 is cancel out. Only 2 remains. 1 plus 2 plus 2 is 4. And that's our final answer. Hope you enjoyed this. And if you have understood this, just tell me in the comments. Love, react, subscribe. And if you still, have some issues with this, just ask me in the comments. And a question for you now, what will be the remainder when 2, 3, 4, 5, 6 in base 8 is divided by, you guessed that right, 7. 2, 3, 4, 5, 6 base 8 divided by 7 base 8. And tell me in the comments. Thank you.